Sir, you are on mute, sir.
Am I audible now? Am I audible?
Yes, sir.
Oh, okay. So let us take one more example of dot product. So vector A is moving in a direction toward right side, and the vector B is also moving in the same direction. So how to multiply them in dot product? So as you see, vector A is parallel with vector B. Both are in same direction, therefore these are parallel vectors. One more thing here, one minute. Students are joining. Okay. So vector A is parallel with vector B. Vector A is parallel with vector B. I taught you this in the last class in the school. What is the angle between them? Because vectors are parallel, there is zero angle between them. So angle is 0 degree because angles both vectors are parallel. So their dot product will be vector A dot vector B is equal to magnitude of vector A product of the magnitude of vector A and of vector B with the angle of cosine between them. So here angle is 0 degree. So as you know, we can represent the magnitude by removing the vector sign above the head of the letter. Similarly, vector B, the magnitude of vector B is also can be represented by the B itself, and the cos 0 produces 1. That is the maximum value of cos. So the dot product will be vector A, vector B into 1. So it will be AB. So this is called maximum value. Maximum dot product is there when the vectors are moving in the same direction. When the vectors are moving in the same direction, then their dot product is maximum. So it is maximum. So now here only I am explaining the product of two unit vectors. So remember this circle. I started in the last class, but the time was up. So let's say it is vector I cap. Yes, beta.
Sir,
Yes.
so can you please explain this A to the parallel B again?
Which one? This?
Yes, sir.
So
No,
this is the
sir.
representation of magnitude. So either
Yes,
you can
sir.
write the magnitude applying modulus and the symbol of vector, or simply you can write A. So I just replace this magnitude of A with the symbol representation, simple representation of the magnitude.
Yes.
Clear? Okay. So now we are doing the dot product for the unit vector. So when you multiply I with j cap, so these are in a relation which are mutually orthogonal. मतलब सारे vectors जो हैं ये हमारे 90 डिग्री पर inclined हैं. with one another. So let's say it is a vector moving in this direction. X is here and the Y is here. These are the 3D axis in this space. Let's say it is X axis and it is Y axis and it is Z axis. So the unit vector in the direction is I cap and the unit vector in the direction of Y is J cap and the unit vector in the direction of Z axis is K cap. I think I explained it also in your class. I explained it already. So if an object moves in the direction of x-axis only, so we can represent its motion with respect to the unit taken in the x direction. Suppose that object started from here and stopped here, and it is the 3-unit separation from the origin to this final point. So this distance will be 3I cap. Similarly, along, suppose that object moved from here to here and it moved 4 units away along the y-axis. So you will write 4 J cap. And the object is moved from origin to K here along z-axis. So you will write, suppose that it is 2 K cap. And these 3 motion of a particle, suppose that this is a particle moving with respect to all these 3 axes. All these 3 axes with respect to x-axis and with respect to z-axis and with respect to y-axis. So this particle P having a position vector which will be represented by 3I cap y-axis component, 4 J cap plus 2 K cap. So it gives us complete information. Now we are multiplying. What happens when we multiply I with the J? When we multiply vector I dot with vector J. So magnitude of I, because it is a unit vector, is 1 only. And magnitude of J, it is also a unit vector. Unit means the value is 1. Similarly, K cap, unit is 1. Means magnitude is 1. It is the magnitude. So what is the magnitude of I? Magnitude of I is 1. And the magnitude of J is 1. And what is the angle between them? I to J. I to J, both axes are mutually at 90 degree. So you will write cos 90 degree. So 1 into 1 is 1 itself. So no need to write 1. So it will be cos 90. And the value of cos 90 is 0. It means in dot product, when the vectors are mutually perpendicular, they produces 0 resultant. So their value is 0. When we multiplied 2 vector quantity which are mutually perpendicular, their product is 0. So hence we can set a law here. And this law is that when you multiply I with I cap with the J cap, it will produce 0. You will multiply in the dot product J with the K cap, it will also produce 0. When you multiply K with the I cap, it will also produce 0, or the vice versa will be true. So when you multiply J with I, then the orientation will be the same. Angle will be the 90 degree only. So it will also produce 0 again. So we can set a law here. So that is vector I cap So when you multiply j cap with the k cap or k cap in dot product with the I cap, there will be 0. Answer will be 0. Answer will be 0. Noted. Have we noted?
Yes, sir. Sir, I'm
Class.
taking the screenshot.
Okay, beta. Okay. Please note it fastly, बच्चों. Aksa, you have noted? Aksa, have you noted?
Yes, sir.
Okay. I'm changing the slide now. So we learned that the dot product when the vectors are in orthogonal condition is 0. So what happens when we multiply vector by itself? So it is again I cap, j cap, and k cap. So vector I dot vector I. Previously we were multiplying I with the different vector. Now I am multiplying I with I only. So there is a law of mathematics that a straight line is parallel to itself. If I say vector A, what is the relation of vector A by itself? So answer is vector A is parallel to itself. Vector A is parallel to itself. It means that angle between A by A itself is 0 degree. So every straight line is parallel to itself using that property of straight line. So vector A is parallel with vector I cap is parallel with I cap, and the magnitude of vector I is 1 only, and 1 into 1, and the angle will be cos 0 because I cap is parallel with the I cap. Because I cap is parallel to itself. Therefore, I have taken the angle as 0. Is it clear? Is it clear,
Yes, sir.
bachcho? So, I dot I cap will be 1 into 0 means 1. Means it will be the maximum. So vector I dot vector I produces 1. Similarly, vector J, we multiply with the vector J, it will produce 1. And the vector K with vector K in the dot product will give us 1 only. So there is one more law here, one more relation we can take. I dot I cap is equal to J dot J cap is equal to K dot K cap produces 1. So two parallel vectors multiplied in dot product produces 1, and the two perpendicular vectors multiplied in dot product produces 0. So now remember these two points, and we will do some numericals. So it was the first rule you can use directly. That is I dot j is equal to j dot k or k dot I produces 0. But I dot I or j dot j or k dot k produces 1. So we can get two values when we multiply a vector to itself, it produces 1. When it is multiplied with the another unit vector, it produces 0. So now let's take one example of work done. So we are having this straight path, and on this straight path, one object started from, it is acted upon by a force. Force is a point vector because it has a point of application. So it is also known as polar vector, because whenever a vector having a point of application, these are called polar vectors. So there may be a question in your exam, what is polar vector? Any vector having a point of application is known as a polar vector. So suppose that a force is acting on this ball, and the force is represented in vector way because it's a polar vector. It is having a point of Am I audible, class? Okay.
Yes, sir.
So this ball is acted upon by this force, and this force displaces this object by a displacement represented by x. So this is the displacement represented by x because it moved in one direction, and it is 2I cap. I'm representing it in 3D, 3I cap, 2I cap, 3J cap, and 4K cap. This is the displacement vector. And it is the force vector, and the force vector is I plus J plus K cap. Now we need to calculate the amount of work done. We will calculate the amount of work done when the object is acted upon by a force of given representation and displaces the body in its own direction by the given equation. So the force is I cap plus J cap plus K cap, and the displacement vector is two I cap, 3J cap, and 4K cap. We need to calculate the amount of work done. As work done is dot product of force and of displacement vectors. So therefore, the work, which is a scalar quantity, will be the dot product of given force with the given displacement. Now put these scalars in the form of vector. Vector f is I cap plus vector j cap plus vector k cap. Unit vector. Apply the dot and now put the vector x. It is 2 I cap plus 3 j cap plus 4 k cap. Now I'm simply multiplying it. For work done, I to I cap, so the scalar of I is 1 and it is of 2. So it will be 1 into 2 I dot I cap plus I to 3. So it will be 1 into 3 I to j cap. I dot j cap plus I to 4, that is 1 into 4 I dot k cap. So similarly with A and with K we will do. So it will be 1 into 2 j dot I cap plus 1 into 3 j dot j cap plus j to k. 1 into 4 j dot k cap. Noted.
Yes, sir.
I'm changing the slide. Next is K with this. So it will be 1 into 2 K dot I cap plus 1 into 3 K dot j cap plus 1 into 4 K dot k cap. So we need to explain because I dot I j dot j and k dot k is equal to 1 and I cap dot j cap with other vectors or j dot k or k cap dot I cap. It produces 0. So you need to note where the vectors are in dot product are same and where they are different. So here k dot k will give us 1 and k dot j will give us 0. K dot I will give us 0. And on the previous slide, j dot k will give us 0. J dot j will give us 1. And j dot I cap will give us 0. I dot k will give us 0. I dot j will give us 0. I dot I will give us 1. So there will be 3 occurrence. The one set will be of I dot I, another will be of j dot j, and the third will be of k dot k. That will give us the answer. The rest term will become 0 because of the orthogonal dot product of these two vectors. So now calculating it. So 1 into 2 is 2 and I dot I is 1. 1 into 2 into 2 and I dot I is 1. Next step is 1 into 3 is 3 and I dot j is 0. 1 into 3 is 3 but I dot j is 0. And the third step, 1 into 4 is 4 but I into k cap will produce 0.
Okay. एक दे दो वो वाली जो पड़ी है वो उसके साथ आए
Tanisha, please switch off your mic, Tanisha. So next is 1 into 2 is 2, but j dot I cap will give us 0. Next, 1 into 3 is 3, but j dot j will give us 1. Now, 1 into 4 is 4, but j dot k will give us 0. So it will be 4 into 0. And now the terms are here. 1 into 2 is 2, but k dot j will give us 0. So it will be 2 into 0 plus 1 into 3 is 3, but k dot j will give us 0. Next term, 1 into 4 is 4, but k dot k will give us 1. So the amount of work done is 2 plus 0 plus 0 plus 0 plus 3 plus 0 plus 0 plus 0 plus 4. So only 2, 3 and 4 is there. Rest of the terms become 0. Why this becomes
The answer is
2?
9.
Because it was I dot I and 3 was j dot j and the 4 was output of k dot k. So the amount of work done is, answer is,
9.
is a scalar 2 plus 5 plus 4 is 9 joule. 9 joule ka work done. Also work done of 9 joule. So it's a long method in order to teach you the dot product of different two vectors given in the vector or component forms. Now, what is the direct method? If you are not having much time in exam, so how to calculate? So it is very easy method now. You can directly multiply I with I in dot product, j with j, and k with k, and you will get your answer. So what was the force vector? The force vector was given as I cap plus j cap plus k cap, and the displacement vector was 2 I cap, 3 J cap plus 4 K cap. So work done. Now we have to calculate the work done. It is very simple. Please listen carefully. We will multiply I with I and the J with J and the K with K only. We will left rest of the terms. We will leave rest of the terms. So the scalar of I here is 1 and it is of 2. So you will write 1 into 2 and I to I means I dot I cap. Now plus scalar of J is 1 and scalar of J in X is 3. So it will be 1 into 3 into J dot J cap plus K. Scalar of K is 1 here in force and in the displacement is 4. So it will be 1 into 4 and K dot K. So the work done will be 2 1 is 2 and J dot sorry I cap I. It was I cap I. I cap I will give you 1. 1 into 3 is 3 and J cap J in dot product will give us 1 and 1 into 4 is 4 and K dot K will give us 1 again. So it will be 2 plus 3 plus 4. So answer will be 9 joule only. 9 joule. The same work. You can apply whichever feels easier to you. It appears easy to you. Is it clear, students?
Yes, sir.
If you have any doubt, you can make it clear right now. I think it was very easy. There will be no doubt. Now we will use, I will teach you the next, that's called dot product. So we have done the cross product. Only 3 minutes are remaining in the class. So I'll try to teach that also. No? So I'm changing the slide. So for dot product, what we do, suppose that we are having vector A moving in this particular direction and vector B is here moving in different direction and this is the angle between them. So their cross product is very simple, or we can say cross product or it is called vector product because the output is vector, whereas in the previous case the output was a scalar. So here in the cross product we multiply vector A and instead of putting a symbol of dot we will put cross, which is also known as Cartesian product. So vector A cross vector B is equal to the product of the magnitude of these two vectors. So magnitude of vector A is A, magnitude of vector B is B, but this time we will take angle of sine between them. Angle of sine between them. As we know that sine theta has 3 values. First is 0. So at 0, sine 0 is 0 degree when the vectors are parallel. When the vectors are parallel. So they produces 0. Now the value is 1 when the angle is 90 degrees. The value of sine theta is 1. In this case, vectors are mutually perpendicular. And the third condition is -1 when the value is 180 degree or phi. Last minute is remaining. Please join class tomorrow now. So it will be -1. Here vectors are, you can take the screenshot quickly, otherwise the class will be off. Okay, bachcho, note it down and we'll meet on tomorrow. I will send you the time of tomorrow's class in the group. Am I audible?
Yes, sir.
Yes,
Okay,
sir.
so bye for today. We'll meet on tomorrow now. You take the screenshot and revise the concept which I taught you today. Please revise the entire concept which has been explained in today's class, and we will move forward in the next class on tomorrow. Please note it down.